Welcome to Season 4 of Stan's Revenge. A new exciting chapter awaits. My name is Noah Almond. I've been experimenting with Stanley Meyer's water fuel cell technology for over 14 years. In previous seasons, I've made exciting discoveries in his technology, namely the operation of the electrical polarization process. This is unlike traditional DC electrolysis where low voltage and high amperage is utilized. As always, no electrolyte or additives are used in my cells. Only ordinary, natural water is utilized. In this season, I pushed the boundaries of my water fuel cell technology further in my latest attempt to break the glass ceiling of 150 volts. Join me as we unlock the secrets. This is Stan's Revenge. Well, just a quick update. I am back in action here. I have not been capped off yet. Got a new stainless steel inductor, tried a copper inductors, wound a new secondary. Trying all these different configurations and just wasn't able to get voltage where I needed to be. Come to find out that the PWM I was using, this guy here, was not providing me substantial input power to the MOSFET. So I switched back to my Chinese PWM here, and that kind of solved that. But nonetheless, I'm just still not getting the voltage that I want. I seem to be capped out about 56 volts or so. I've tried numerous different configurations here. I'm in this scenario getting pretty good, kind of almost equal opposite polarity pulse during the off time. But just man, getting frustrated here with just not being able to achieve the voltage that I had previously had. And I have fresh, water in my cells, configs. I'm thinking maybe the connectors that are inside my cells are kind of mashed up and maybe not making really great connection, maybe too much resistance. But even so, like disconnecting this and turning this on, I should be getting a substantial amount of voltage here. Thousands of volts per se, but I'm only able to achieve a couple hundred volts. Maybe it's these relays that are the culprit, but any rate here, man, I'm just scratching my head to why I'm not able to achieve voltage as I had been previously. So still at it here. Just want to give you an update here. Haven't put out a video for a good while. I have been busy with many side quests of life. So getting back at it here. Hopefully you'll see more videos coming at you here within the next weeks to months. You can see here I just absolute mess here as far as my alt projects. Alright, so means of troubleshooting here. Looked up one of my old videos, create HHO with no electrolyte, easy mode, and I show just hooking up a toroid transformer with no inductors, just directly to my water fuel cells, water capacitors, and I'm getting excellent results. I'm doing this to see if these cells are working, or if it is maybe my new VIC circuit, matrix switchboard, or something of the sort that is causing me all my frustrations. This is not the same transformer there. We're going to give it a go. It might be, but I don't think it is. I moved my power supply down here just because I wanted to be able to see this while I was jiggling cables over there. I like how my master control switch also powers on the PWM. My video said 600, we're going to start at 600. No voltage, strange waveform. Even after switching around diodes and stuff like that, something's not right. Oh yeah, we're missing my inductor B bridge. Now where'd that wire go? Bruh. Just had to make a new one. Test 2, go. Better waveform. Still no voltage, and that's because our diodes are not turned on. You'll see this is just alternating current, positive and negative. Pretty simple coming from that toroid. We turn on diode 1, if we turn on diode 2, diode B you could say, look at that. Look at the difference in that. That's the diode A, let's call it. This is diode B. So this is both off, and this is both on. Interestingly enough, let's try to reverse some of those diodes. That's reversing B. Whoa, wild. Let's see what happened there. This is reversing diode A. Whoa, look at that waveform. Let me see if I can stabilize this. There we go. Okay, so back to both diodes enabled, reversing diode A. Wow, look what that does. And reversing diode B. That's both diodes enabled and reversed. We're back to diodes in normal position on. We're going to reverse diode B. Wow, dude, did you see that whole waveform change? Wild. Okay, let's get like a real good view here. Yeah, watch this waveform here. Diode A reverse. Look at that change. Whoa, equal opposite polarity building on the pulse on time. Interesting. And also reversed because we should have blue on top, people. There we go. This is diode B reversed. We can see polarity is also needing to be switched. This is this configuration here. Bam. So interesting. Let's play around with this. This is reversing the polarity on the output. Watch this do that funky thing. Cool. That's equal opposite polarity on the off time, as you can kind of see there. Let's crank up the voltage a little bit. 20 volts, not much difference. We're just introducing noise. Interesting. Okay. Only about 25 volts at the cell, and pretty much no amperage. This configuration gets me about 44 volts in the cell, 14 volts input. I don't know if we can go much higher. We are at 20 some volts here, but no difference at the cell. Cell's pegged at 44 volts. Put the frequency up to 3.5K, and that's our waveform, 39 volts. What you'll see here is, what's interesting is that we're at 50% duty cycle right now. In this specific scenario, when we reduce the pulse width, voltage actually increases to a maximum amount, about right there. That's at 30% duty pulse, which brings us down to 0.21 amps, about 200 milliamps for 52 volts, but that's simply not enough to get any production on the cells. You see just the tiniest bit on that first cell. Once we get up to 23 volts, anything over that is just noise on the primary and MOSFET. You can see in the red and the yellow. But yeah, struggling to get the voltage here. 52 volts, and anything over that just really doesn't do much. We might have a problem with our cells. Let's run a little test.
This is Stan's Revenge.